Hello everybody, and welcome back to page 31 in the workbook. And just to remind you of what we finished off with in the last video, we introduced these new terms of concave up and concave down for a function. Basically, we're going to call a function concave up if its second derivative is positive and concave down if its second derivative is negative. What was missing from our discussion is what does a function look like if it's concave up, and what does it look like if it's concave down? We'd like to fill in the missing blanks in those two comments, and we can do that by just doing a little thought experiment here. Okay, so let's go to the next page. Okay, we'll look at example 2, and I think that will lead us to a graphical description of concave up and concave down. All right, so let's read this together. So for each function, decide whether the function is concave up or concave down and give a reason. Okay, so first of all, let's look at the function on the left here. So concavity, concave up or down, is about the second derivative. And remember, the second derivative is the rate at which the derivative is changing. Okay, so it's asking us about how the slopes of our function are changing. So what we'll do with the first function here is just to draw in some tangent lines. Okay, and see if we can notice some patterns here maybe. Okay, and the question that I have for you is, how are these tangent line slopes behaving? Okay, well, we don't have enough information to determine the numerical value, so I'm just going to kind of take a shot in the dark here. I notice that the very first of the tangent lines over here has a positive slope. Let's just say, for the sake of argument, that that slope is 10. Okay, and then the next slope is still positive, but it's not as positive. Maybe its slope is 5, let's say. Okay, what would the slope of this line right in the middle be? Well, that's horizontal, so its slope is probably 0. And then we can see that these two slopes are negative, so maybe they're -5 and -10. Okay, my question to you is, as you look at those slopes from left to right, are the slopes numerically increasing or are they decreasing? So we went from 10 to 5 to 0 to -5 to -10. Notice that those numbers are decreasing. They're getting smaller. Okay, so we could make the following observation here. Since the tangent line slopes are decreasing left to right, we know that the derivative function is decreasing, okay, because the derivative is the slope of the tangent line. Okay, but if f prime is decreasing, then the derivative of the derivative has to be negative. So what we could say is that f double prime of x is negative. Okay, well, if the second derivative is negative, that by definition is what we mean when we say that f is concave down. Okay, so because of that negative second derivative, we are looking at a concave down function to the left here. All right, let's compare that with what's going on in the function to the right. We'll do the exact same thing, just start by drawing in some tangent line slopes. We're interested in determining whether those slopes increase or decrease. Okay, and if we kind of make up numbers based on what we're seeing, the very first tangent line slope is really steep and negative. Maybe it has a value of -10. Okay, and the next one still negative, but not as negative, so maybe it's -5. Okay, then a slope of 0. And maybe 5 and 10. Again, we don't know for sure that these are the numbers. We're just taking guesses based on kind of the magnitudes of the slopes that we're seeing. And now kind of the same question to you. So as you look at those slope values, do they get bigger or smaller as we go left to right? So we're going from -10 to -5 to 0 to 5 to 10. Notice that this time, those numbers increase. Okay, so we could say that since the tangent line slopes increase, we know that the derivative increases. Okay, and if the derivative increases, that means that its derivative, that is the derivative of the derivative, is positive. Okay, and a positive second derivative by definition is what we mean when we say that a function is concave up. Okay, so we have determined the concavity of these two functions. The next question is, do we notice any, can we make a graphical observation here? So I'm going to clear away all of these lines just so we can see the graph a little bit more clearly. My question to you is, how would you describe the shape of the concave down function on the left? Notice that it kind of has the shape of an upside down bowl, whereas on the right it's the opposite. The concave up function kind of has the shape of a right side up bowl. Okay, so those two graphical descriptions were what we're missing from the table on the previous page. Let's scroll back here and fill those in. Okay, so kind of what we've discovered here is that a concave up function appears to have the shape of a right side up bowl. Okay, and concave down, it's exactly the other way around. All right, so we now have a graphical way to think about the second derivative.